Okay, you just did a bunch of simple Lewis structures that had what we call single bonds in them. Let's take a look at another molecule, oxygen, O2. If we're going to go ahead and do the structure for oxygen, each of those oxygen atoms has 6 valence electrons. Let's go ahead and draw that. I have an oxygen with 1, 2, 3, 4, 5, 6. It's unhappy, doesn't have its octet. It has 2 places it can bond. Now, if I draw another oxygen atom with 1, 2, 3, 4, 5, 6, it also is unhappy, doesn't have its octet, has 2 places it can bond. So we start searching for pairs that we can share. So I can share these 2 electrons, but then I still have these 2 that are hanging around. Those can be shared as well. Now, if we share a second pair, what we end up making is what's called a double bond. Double bonds are stronger and shorter than single bonds. They pull those atoms tighter and closer together. So our Lewis dot picture will look like a pair and another pair between the oxygens, but each oxygen still has 2 lone pairs on it. Each atom right now has its octet, 2, 4, 6, 8 around it, 2, 4, 6, 8. Or it's a little nicer to draw it using the lines instead of the dots. I could draw oxygen with 2 lines equally distant in between them, like an equal sign, and then still draw the 2 lone pairs on each oxygen. 2, 4, 6, 8, 2, 4, 6, 8. Let's try another one. What about C2H4? If we look at C2H4, which is called ethene, we have a carbon atom that has 4 valence electrons, and we have some hydrogen atoms, each with 1 valence electron. Let's start with the carbon. Each carbon has 1, 2, 3, 4 places that it can make bonds. I've got 2 of those carbons, 1, 2, 3, 4. So I know I can go ahead and at least link them up and make a bond in between them. Now, I've got 4 hydrogens to stick onto those carbons. If I go ahead and put a hydrogen on each one of these ends, 1, 2, 3, I can put the 4th on the left, but that's going to leave a little bit of weirdness because I'm going to have 2 electrons that are just hanging around simple by themselves. I probably am not going to want to do that. Instead of doing 3 hydrogens and 1 on the other side, symmetry tends to be really good in chemistry. How about do 2 and 2? If you do 2 and 2, you're going to have a hydrogen over on the right, 1 hydrogen with its 1 valence electron to make a pair. We're going to put another hydrogen on the right with its 1 valence electron. We have a pair we can share. Then I'm going to put the other 2 on the left. A hydrogen with its valence electron, a hydrogen with its valence electron. We can go ahead and share, but now everything doesn't have partners over here. So what we can end up doing is sharing a second pair between the carbon atoms and making a double bond. Now, if you draw that as a line structure, you're going to draw the 2 carbons with a double bond between the middle, and then you have a hydrogen. Doesn't matter if you draw it to the top, the bottom, the side, as long as there's 2 single bonds to hydrogen. We have another hydrogen on the left and another hydrogen on the left. Hydrogen has its complete shell just with 2 electrons, so 2 on every one of those hydrogens, 2 in a line. And each carbon should have 8 around it, 2, 4, 6, 8. And again, double bonds are stronger than single bonds, and they're shorter than single bonds. I hope that helps. Take care.